I'm going to build on what Anache said.
You have another weight to add onto hers.
And is 2/10 equal to 1500ths or not equal to?
Nice.
How do you know?
If you put a line right here, then it would equal 2/10.
If you did that, that would be equivalent to what Lee did right here.
But Tina was right. Yeah, she got it okay.
No more pitfalls.
Math Pathways and Pitfalls is a set of intervention lessons for kindergarten through 8th grades. These materials are research-based and focus on key mathematical concepts. This video will introduce the unique features of the lessons and provide professional development for teachers planning to use them.
A primary goal of the Math Pathways and Pitfalls program is to help students develop a robust mathematical understanding that doesn't cave into pitfalls.
Well, the way I explain pitfalls to my students is that it's a mathematical mistake that's easy to make.
Usually when you make a pitfall, it throws off your whole answer.
When the children are explaining it written down, there is a flaw in their thinking.
It's good to talk about pitfalls because you'll know next time. And because my father said mistakes help you in life.
People give more ideas to my ideas. I felt really good because I knew that when I got those ideas into my head, I won't make that pitfall anymore.
Another goal is to help students learn to communicate their mathematical reasoning orally and in writing. Teachers tell us that these skills quickly spill over into other curricular areas.
Ultimately, the goal is for all students to improve their work in class and on assessments.
Math Pathways and Pitfalls applies relevant research on the way students learn mathematical concepts and language. It has also been evaluated in a nationally acclaimed experimental research study with randomized groups. This study was conducted in 107 classrooms with ethnically, linguistically, and economically diverse students. On average, students in Math Pathways and Pitfalls classrooms had higher post-test scores than in the comparison classrooms after controlling for pre-test scores.
Teachers with different backgrounds and a variety of teaching styles obtained these results. Let's hear what they have to say about these lessons.
This is cooperative learning at its best. You have students working together, and then you facilitate a discussion, and students are actually excited about expressing their ideas about a mathematical concept.
Being able to describe what is going on and why tells more about their understanding. At the beginning of the process, they were guessing. They didn't know how to attack these problems. By the end, not only could they do some of these problems, they could explain it to someone else, they could explain why they were doing what they were doing, and they could also explain pitfalls. What is something I don't want to do?
So it deepened their mathematical thinking, and that actually went into other curricular areas as well. They start asking questions about their thinking. They question one another in a respectful way.
Their academic English language improved immensely. They enjoyed it. They had fun doing the math discussions. It developed their confidence in public speaking.
The components of the Math Pathways and Pitfalls program provide everything needed to ensure the program's success.
When you don't have a lot of time to prepare, the teaching guide is great because it really takes you through the most important things that you need to know about where students could have misconceptions, what are the most important objectives for what you need to have students learn at the end of the lesson. It really helps you also in, if you're not super confident in your own conceptual understanding of that area, it really supports you. There's also these little parts that are highlighted or bullet pointed that you really need to pay attention to. And so if you take a few minutes to look through that at the beginning of the lesson, and then you look through the entire lesson, it's very clearly laid out for you, then you really can, in a very short amount of time, be very well prepared in order to teach the lesson.
I start with discussion builders as part of my language in speaking to the children and giving them prompts when they speak to one another. And it could be about any subject. So it starts with discussion builders. And then, so it starts with building their self-esteem and being able to speak about any subject and discuss any subject. And from there, we go into the mathematical concepts.
The language support section is really important because what it does for you as a teacher is it makes you more aware of what are going to be the specific vocabulary terms that students need to know in order to understand the concepts in the lesson. And it allows you then to front load that vocabulary for the students at the beginning of the lesson. That's really important for English language learners because otherwise they might get lost in the middle of the discussion.
Well, there's always in first grade there's one mini lesson, and in the upper grades there's your 2 mini lessons. I think that's kind of another assessment, and you may be surprised by the answers on the mini lessons and also their explanation that maybe they did in actuality get it.
Math Pathways and Pitfalls lessons focus on the most difficult standards. Units K and 1 focus on early math and whole number concepts, while Units 2 and 3 integrate place value concepts and whole number operations. These primary grade lessons also set the stage for later work with algebra. Units 4 through 7 are organized by math topic and include fractions, decimals, percents, ratios, and proportions. Fundamental algebra concepts are woven into each of these topics.
Students like using the Math Pathways and Pitfalls materials. Even students who are shy or feel less confident are supported as they learn to present their own ideas, build on each other's ideas, and sometimes respectfully disagree with an idea presented.
The discussion builders help me because they get right to the point.
I'd agree with Jazray. I disagree with that answer. I agree with Jer's idea.
The one I like to use the most is I'm confused about, because sometimes kids don't explain enough.
I'm a little bit confused.
I'm confused about his answer.
You can help out the person who's doing the problem and not be rude.
I disagree with Jazray. We did it a different way.
Now that you have an overview of the Math Pathways and Pitfalls program, we'd like to invite you to view Part 2 of the video.
In Part 2, you will view a Math Pathways and Pitfalls core lesson in action and walk through the student pages and teaching guide. In the third part of the video, you will hear teachers respond to common questions about how to implement the lessons.
Now you'll see a 5th grade Math Pathways and Pitfalls lesson in action. Beginning with day 1, you will see how the lesson is introduced by going over the purpose, the math words, and the starter problem. Continuing on day 1, you will see students participating in a discussion. Finally, you will see what happens on day 2 as students review the previous day's discussion and practice on their own. After each segment, you will be prompted to stop the video and complete tasks from your Math Pathways and Pitfalls teacher's manual. Now let's view a teacher introducing a lesson called Decimals or Fractions 2 to her 5th graders.
Here's day 1.
So, boys and girls, we're going to start this morning by reviewing our discussion builders. So I'd like you to take a look up at the chart, please.
Building on another's idea. I have a question about Blank's idea. I understand Blank's idea, but what about, I'm confused about, I'd like to add to Blank's idea. I agree with Blank's idea because.
Would that be true is there another way? Can we think of a counter example?
I'm going to ask you to make sure to use these discussion builders today, and I want you to especially focus on the last one.
How could we prove it?
And I'd like you to ask people who come to the front, if you feel like they haven't proven their idea, I'd like you to say, how could we prove that? Okay? Let's go ahead and read the purpose of today's discussion. Can I get a volunteer, please? Angel.
Find equivalent decimals for fraction amounts.
Thank you. Now we're going to go over some math words that will be important in our discussion today. And what I'd like you to do is, as I say them, I'd like you to say them to yourself quietly. Okay? Decimal amounts are in tenths, hundredths, and thousandths. I want you to think of an example. An example I'm thinking of is, for example, 4 tenths, or 45 hundredths, 360 thousandths. Decimal point. Whole numbers are to the left of a decimal point, and parts of the whole are to the right. And let's think of the example 3 and 5 tenths. There's 3 wholes, and then 5 tenths of the whole. Okay? We're going to go ahead and do a starter problem now. And again, I'd like you to read this quietly in your mind as I read it out loud. 1/5 of this rectangle is shaded. What decimal amount is shaded? I'd like you to work on this problem on your own. And as you work on it, I want you to think, where might somebody make a pitfall? Take about another minute to finish working on your own. Please remember to think about where somebody might make a pitfall. You might have a pitfall if your answer to this question has the digits 1 and 5. But that's okay, because that's why we're going to do this discussion. We're going to learn about that pitfall.
Now that you have seen how a core lesson is introduced on day 1, please turn to the Professional Development section in your Math Pathways and Pitfalls Teacher's Manual. Then complete Task 1. Upon completing this task, you may resume the video.
It says okay next to Lee's work, and let's read what he said. I needed a decimal, so I called the whole rectangle 10 tenths. There are 10 tenths in all, so each of the 5 parts has 2 tenths. I could have called the rectangle 100 hundredths, or 1,000 thousandths too. On your own, I'd like you to try and figure out why Lee said that since he needed a decimal amount, he called the whole rectangle 10 tenths. Please share what you've written and drawn and talk about why would Lee say that that whole rectangle is 10 tenths?
It was 10 tenths because when you make a decimal, you need to have like tens, thousands, hundreds.
¿Cuántas veces la una? Esto, 10. ¿Era una 10? No, son 10 entre 10.
You could color too. That's a kind of pitfall. This one is not a pitfall because I color 2 tenths, and that's equivalent to this one.
I agree.
Now we're going to go ahead and use our discussion builders to talk about Lee's ideas. And I need a volunteer who would like to come up here and share their thinking about Lee's work. Leslie.
I agree with Lee's idea because I think he already knew that you can't write 1/5 as a decimal, so he had to split them into tenths. And if this is 1/5 and it's not in tenths, he decided to split each fifth into 2 tenths. And the 1/5 he shaded in is 2 tenths.
Could you explain why he wrote 10 tenths or 1 whole above that diagram?
Because each fifth he split it into 2 tenths became in the whole rectangle as 10 tenths in total.
Would somebody like to respond to that? Angel.
I agree that she said 10 tenths, or like how she had 10 tenths, 100 hundredths, or 1,000 is equivalent to a whole. So he could have put like 20 hundredths or 2 tenths or 200 thousandths.
I'd like you to take a look at your paper and look at what Lee said. I'd like you to think about what Lee meant when he said, I could have called the rectangle 100 hundredths or 1,000 thousandths. Angel discussed that up here. But I would like you to talk to your neighbor about what did Lee mean when he said that, and could you come up with any diagrams that prove that?
We had tenths, and how would that be 2 tenths? But now we divide it in hundreds, and then it's 20 hundredths. And if we divide this in thousands, it would be 200 thousandths. So like it's the same thing. You just keep adding zeros and like more little squares.
Also, if you drew tenths right here, like there's 10 tenths, and then the 1/5 is shaded, and then I did hundreds, and then I shaded 20 hundredths, and it was equivalent 2 tenths with 20 hundredths, and then I think it will be the same thing with thousands and 10,000s. And I could have done 1,000, but that's a lot of squares, so I just did 100. There, I did 100. I colored it in, and it equals 1 whole. And this, I color it in, and it equals 1 whole. They're all the same.
I'm wondering if somebody could come up and show us what 100 hundredths would look like. Jose.
Like me and Eileen were discussing that we could just like draw a diagram in tenths, then divide it in hundreds, and then we could shade in 2 of them. That would be 2 tenths, but we don't have to make another diagram because you could just add in hundreds. It'll give you the same answer, except it'll be 20 hundredths. It don't make a difference, like Angel said right here.
I would like you to take a look at Maria's work. Maria said, how easy. 1/5 is the same as 0.15. You just put a decimal in front. Maria made a pitfall that lots of students make when they do a problem like this. What I'd like you to do now is I'd like you to share your ideas with your partner.
It's also incorrect because she just took the number from a fraction, and when you do a decimal, you have to put into tenths, hundreds, or thousands. And she just like put the number from the fraction, and those numbers were in tenths, hundreds, or thousands. Exactly.
How could you see if that's equivalent or not?
No, it's not 1/5 because it will be 2 tenths or 200.
And is 2 tenths equal to 15 hundredths or not equal to?
Not equal to.
How do you know?
Because Maria, she probably just said that she put 1 right here, the 1 or like 1 point. She probably did that, but I disagree with her because she's supposed to like multiply this 2 by 2. You get 2 tenths, so it'll be 2 tenths.
Okay. So is there somebody who could come up here and show us how they know that 1/5 is not equal to 15 hundredths? Evelyn?
This is 15 hundredths. That's 2 tenths. So 2 tenths is bigger than 1500.
Angel?
I agree with Evelyn's idea because 2 tenths is 20 hundredths, and 20 hundredths is 5 units away from 15 hundredths.
Thank you. Monica?
I agree with Evelyn because it's not true that 1/5 equals to 15 hundredths. Because I was telling my partner that maybe Maria thought that the line could be the point.
What do you mean that Maria thought the line could be the point? Could you show us that?
You know, like Maria said that 1/5 equals to 1500s. So I thought that maybe she thought that this line would equal to the point.
And so would that be correct or incorrect to think that that's the point?
Because sometimes the line is the it told us that it's also the division line.
Okay. Would you label that as a pitfall so we don't get confused? Thanks, Monica. What I'm going to ask you to think about now is, what do we need to remember so that we don't make pitfalls like this? I'd like you to discuss with your partner for a moment what you think is important to remember, and then I'm going to take some of your ideas.
To compare that drawing with the other drawing, like we found out that 1/5 is equal to 2/10. You shouldn't think the line should be a decimal point. When you do multiplication and pictures, you can give examples like what's this and what I'm doing.
All right, boys and girls, I'm going to ask for a quiet hand for somebody who would like to share something you think we need to remember so that we don't make pitfalls like this in the future. Eileen.
I think that you should remember that when you're turning a fraction into a decimal, to turn the denominator into tens, hundreds, or thousands.
Thank you, Eileen. Roberto?
Another thing we should remember is not like to confuse the fraction line into a decimal point.
Thank you, Roberto. And Iris.
I think we should remember to draw a diagram to see so you could imagine like how it would look like to draw a diagram.
And I'm going to push you a little bit. What would you want to imagine in each part of your diagram? What would you want to put on the diagram?
Like the fraction, like in a decimal, make the fraction to a decimal and try to imagine where they go.
Okay, so let me clarify if I have that right. So draw a diagram, and for each part, write the fraction in a decimal form? Is that what you meant? Okay. All right, thank you very much. Go ahead and add the things to remember to your paper so that you'll be able to remember that for tomorrow's discussion. Let's take a few minutes to reflect on our discussion builders. So somebody who'd like to share a discussion builder that was used during today's discussion and how it helped us discuss the math? Edgar.
I want to add to Blank's idea, and it helps us because it makes the discussion stronger.
Why? Why does it make the discussion stronger?
Because it's lots of people worked on it.
Thank you. Monica.
And the one that I agree with Blank's idea because it helped us because if you disagree, maybe somebody could be right or wrong. If you say every time that you agree, maybe you will find the right answer. And how could we prove it? Because every time when people talk, some people ask, how could you prove it? To make sure that they were right.
You have now viewed day 1 of a core lesson. Please turn to the second task in the Professional Development section of your Math Pathways and Pitfalls Teacher's Manual.
First, we review our discussion from yesterday.
I'd like you to look over page 1. See if you can remember what we talked about during yesterday's discussion. Could I get a volunteer to explain what did Maria do that was a pitfall? Jose?
She just guessed and put 1/5 together and put a decimal point in front.
Okay, thank you very much. What I'd like you to do next is I'd like you to review our things to remember. You can either read the chart or you can read things to remember on your own paper. I want you to read each item very carefully. Take a minute to do that, please.
Now it's time for our turn.
What I'd like you to do now, please, is turn to page 2, where it says decimals or fractions 2, and it says our turn. I'd like you to look at the first problem, please. 4/5 is equal to, I'm going to ask you to write a decimal name in tenths or hundredths for that shaded part. Please do only number 1, and I'd like you to work together with your partner on this.
And if you multiply, let's multiply 4 first. So it's 4/5 times 2 equals 8 tenths.
Multiply by 2. Or cut it like that, and it will equal 8 tenths or 0.8 or 8 tenths.
So I'm going to ask for a volunteer to come up and share with us what decimal amount is equal to 4/5. What did you and your partner discuss? How did you figure out what's a reasonable answer? Edgar, would you come up, please?
We thought that it was 8 tenths because in decimal you have to make it into tenths, hundreds, or thousands, and so you had to make this into tenths. So we just did each one. We divided by 2. It's kind of cut into 10th parts, so then it's 8 tenths. And also, you could do it by because 4 times 2 equals 8, and 5 times 2 equals 10, so it's 8 tenths.
Edgar, would you be able to label your diagram how much each piece is worth in a decimal amount? Okay, thank you. All right, I would like you now to look at the second problem. And I'd like you to go ahead and, again, work with your neighbor on the second problem, find a decimal amount, and I'd like to hear you talking as you're working. Okay? So it's now your turn to do some problems on your own. I would like you to remember everything we've discussed yesterday and this morning as you're doing these problems. And for every problem, keep in mind, what's a possible pitfall that I could make here?
This concludes the 2-day lesson. Please complete the third task in the Professional Development section of your Math Pathways and Pitfalls Teacher's Manual. When you finish this task, you are invited to enjoy Part 3 of this video. In this segment, teachers who have used Math Pathways and Pitfalls lessons in their classrooms answer some frequently asked questions and leave you with some things to remember.
I wanted to know, how do I get started?
What if my students don't talk?
What if my students don't use the discussion builders?
What if it's too hard?
What if it's too easy?
How much do I have to prep?
As you get started using Math Pathways and Pitfalls, you might have some questions about how this will work in your classroom. Not to worry. In this part of the video, we'll respond to some frequently asked questions.
Even before we get into the core lessons, we discuss how you should respond to someone's answer, whether it's correct or incorrect. And so there's already a trust that's been established amongst the students that they can share and not really feel embarrassed if they have the wrong answer.
Watching the video first helps them see what the older kids do. So, and if you've gone over the discussion builders, they understand the language already, so they see it in action, and then they kind of have an idea of how they're supposed to answer or respond during the discussion.
After you've taught the core lesson, a day or two after that, you're going to do the mini lesson, and that's a good informal assessment to see if they got it.
In my classroom, often these lessons unearthed some really important misconceptions, and sometimes we needed to do more in talking about other ways of attacking the problem and reinforcing even more some of the mathematics behind it.
So the Math Pathways and Pitfalls program doesn't take a huge amount of time. What I've done with my 5th graders is I space it out. We do one discussion every few weeks. And you know, the core part of the discussion takes 2 days. Each time you're teaching about 45 minutes to an hour, and then 2 mini lessons, which are really quick. And you can do a mini lesson and then do your regular math program. And I think it's time well spent, because a lot of times in textbooks, they don't spend a whole lot of time developing students' conceptual understanding of rational numbers. And so this way you're building it all through the year. And a lot of students who might not developmentally be ready early in the year, by the end of the year have developed a very solid understanding.
This program is excellent regardless of whether you have access to manipulatives or not, because the drawing, the aspect of drawing, factors in so heavily. The students are drawing, the teacher can draw. If you have an overhead projector or any kinds of whiteboard, chalkboard, paper on the walls, there's no need in some cases for manipulatives, because the students are so active in the drawing of the pictures.
We first of all discuss the OK, because we want students to understand why the concept and the answer that is there makes sense. But we also discuss the pitfall, because this is a common misconception, and some of the students may have had it themselves, and it's important for them to understand why they had that so that they don't make the mistake again.
So often in mathematics, especially in the upper grades, kids have been making the same types of errors for a long time, and they don't get an opportunity to talk about it, to talk about why would somebody make that error? Why am I making that error?
Your initial response is to try to avoid having them make that pitfall. But I feel that at times making the pitfall lets them know where they've made the mistake, and it will show them ultimately how to avoid that. So I don't always think that making pitfalls are a bad thing.
When the students are talking with their partners and they make a mistake, I'm walking around listening to them, and if I hear it, then I will go ask them questions to help them see what they've done and to help them clarify their thinking.
They can feel safe because they aren't out there alone. Other children may have a response and be able to aid the child that's there. And so it's not you're wrong. It's like, I'm confused about that. And they can stop and think. And then they say, have you ever done it this way? Is there another way? I have an idea. I have an idea. And then they're welcome to come up and assist. And so it's a support system in their thinking.
One thing that you can do when your kids are really shy or too embarrassed to go to the board is you can circulate around while they're working with their partners. And I always carry a clipboard and I take notes about what kids are saying to each other. And if I see a kid who's maybe shy, who has this really solid idea that I know they'll have some success up at the board, I note that, and then I specifically ask them to see if they're willing to give it a try up at the board.
I think you'll find that students will come up as they see other children coming up. It becomes something that they feel very comfortable with. And of course, as I said, you don't use the discussion builders and you don't ask children to just come up during math. You ask them to do that during every other curricular subject as well. And so it is part of their day, and it is part of who they are. It's part of their learning environment. It's not just for mathematics.
I've had experience where students will say, and they'll do the problem correctly, but they can't say why they've done it correctly. They can't understand what they went through or can't verbalize what they went through to get that correct answer. Whereas when you start discussing and they start to partner share, or when it comes out in the class discussion, those mathematical ideas and those concepts begin to come out. And children who say, well, I know because I did it right. I can do the algorithm, so I know that it's right. but they have a way of explaining why they are correct. And I think that's an important piece in children's thinking.
I think if you're a teacher who's not very comfortable facilitating discussions, I think this is a great program because it helps develop your capacity as a teacher to do that. For example, it provides prompts for you as a teacher that you can use in order to keep the discussion going. Things to say when you notice your students getting stuck in a certain area. And so if you're somebody who hasn't done that in the past, you know, the program is kind of like scaffolding for you to build up to a point where you can do that. The format of the discussions works really well for older kids. I think because older kids tend to be somewhat self-conscious about sharing their ideas in front of a larger group. You know, they don't want to be embarrassed by, you know, sharing a wrong response. The format of the discussions allows kids to engage at different levels. It allows them to do individual work, to share an idea with a partner, and so they can try out their thinking on somebody without, you know, having to be on the spot.
Developmentally, they're starting to solidify their own ideas and kind of move into more abstract young adult type thinking. Giving them an opportunity to discuss and have ownership of some of these ideas is excellent.
I feel very strongly that this program helps second language learners immensely. I believe that because of the structures that are built in with the front loading of the vocabulary, giving students the language for academic discourse with the discussion builders, and it's at a level where they can handle it, but it also pushes them to up their level of English with the different types of participation that are built in, individual, partner, whole class. It really gives English language learners a safe structure in which they can practice their skills.
One of the mini lessons comes in a multiple choice format, and most standardized tests are in the multiple choice format. And so they've already been through the thinking of what is correct, the okay, and what is the pitfall. And a lot of standardized tests have answers built into them that are pitfalls. And so the students, they have already looked at the question and they're saying, oh, this is a pitfall here. I don't want to answer that one. I want to look for the correct answer.
I think that looking at one problem particularly and really looking at it deeply really helps the students to decide, to learn, to get into the habit of thinking about problems before they answer them. I know a lot of times on worksheets I'll have students just do the problem and they'll think they've got the pattern and they'll just do the same thing all the way across. And they'll fall into a pitfall sometimes because they've done that. So if they actually stop and look at the problem and think about what that problem is asking them to do, then they will more likely not fall into the pitfall and they will get the correct answer. Because on the standardized test they'll have a multiple choice and that pitfall answer will probably be there.
In the beginning, my special needs children were they weren't participants, they were observers. And the children who normally raise their hand and participate were the only children. And so it was the same people over and over again. As time went on and we went through more and more lessons, children who didn't speak at all because of certain traumas began to open up and express their thinking. Children who normally would not read anything aloud, even in the video that we made, read on tape. And children who normally would just sit back and let everyone else do the work, they wanted to be a participant. I didn't have to, badger them and say, come on, come on. They wanted to do that. They wanted to shine, and they did shine. All of the children did shine.
Please make a list of other questions you have. Then later you can refer to the teacher's manual and talk to your colleagues to come up with answers to your questions. Now you'll see teachers discussing teaching tips and things to remember when using the Math Pathways and Pitfalls lessons.
So,
The reason we're here is to talk about things to remember when we use Math Pathways and Pitfalls materials. And we want teachers to know what we think is important to remember when we teach using the materials.
As you begin the program, there's a section in the beginning that you don't want to skip over. I highly recommend you not skip over. It's very important for the students as well as for the teacher to start with the Getting Started chapter.
In the Getting Started materials, that video is really a teaching tool to show what day 1 looks like, what day 2 looks like, what on your own or your turn or on your own look like, so that students say, oh, yeah, that's what was on the video.
When we brainstormed, almost everybody wanted to talk about the use of the discussion builders and why that was important. So would you like to start with the discussion builders?
The discussion builders in the Math Pathways and Pitfalls really gives the students and the kids the language and how to talk to each other, to the teacher, and to really use communication.
I even used it in social studies before I used the other Getting Started materials, just so that they could get used to expressing themselves. And when they first saw the Getting Started video, they had this aha. They saw, hey, those are the questions that we've been using. And so that really added to help them express their mathematical concepts.
I think it's also very important to begin with one aspect, either building on others' ideas or eye-opening ideas, something very positive, because many children in the beginning are shy about saying something about another person's ideas, about their peers. But as they use, for example, I'd like to add on to another person's ideas, it's a positive.
I think it was important to know that a lot of the students were able by the end to say that they disagreed with somebody and that it was okay to talk about what somebody was talking about but not agree with them, or to have another idea about how they approach the problem.
I'd like to add to Sandy's idea, because I think the discussion builders really help students develop the capacity to work through misconceptions and to help each other as classmates work through mistakes together. I think it's also really important that the discussion builders support students in developing multiple ways to approach a problem. And I think one of the most important things for the teachers to remember as they're implementing a discussion is to give students the space to do that, to encourage them to struggle with math, within their zone of proximal development, but to let them work through it and to allow them many, many opportunities to show their learning.
Earlier, we talked about how important it was to read the math background information and the teaching tips, and you specifically wanted to talk about certain parts of the math background. So who wanted to start talking about that?
I found the mathematical background page to be particularly helpful. It helped me to think about what I needed to know and what I needed to help the kids to know, and how I could get them there, because there are prompts on the page that you can use, and it gives you lots of information to help you understand what it is you want to get across.
Oh, the teaching tips are really great for me as a teacher, because they're short paragraphs on important things that give mathematical background on the lesson, just little bullets or flags that help you to remember this is important, an important concept, tips that you need to do while teaching the kids.
You wanted to talk about what if students make a mistake, or what if they are embarrassed to come to the board. So who would like to talk about that?
I think it's really important that the discussion process builds in multiple ways to maximize student participation. I work with adolescents, and adolescents are notoriously self-conscious about making mistakes in front of their peers. And I think from the very beginning of the discussion process, where you're front-loading vocabulary so that they know the types of words that they need to be using, to the part where students are having some time to work on their own and to work through the problems, so they know they have something to share, and then the opportunity to share with a partner, so that there's that safety of testing your ideas out on somebody. Mm-hmm. That lowers the affective barrier of the student. And then finally, like Sandy was saying, the opportunity to use the discussion builders to talk about the ideas. I think that while in the beginning you're still going to have a number of students who are too shy to share their ideas with the whole group, at least at that point, they're sharing their ideas with one person. And then as the weeks go on and you use these discussions over and over, students start to notice that it's okay to make mistakes. Other people are up there, with misconceptions, and the class works through it in a safe manner. And you'll see by the end that, pretty much the whole class starts to participate and be willing to share their ideas with the whole group.
My first graders kind of looked at me like, what? What do you want me to do? But I found that when I started asking them questions, I could get them to come up to the overhead projector. Was a great thing for them. They loved to come up there and show what they were thinking. So I'd like for teachers to remember that really, if you start asking them questions and you provide them the opportunity to come to the front of the room, somebody's going to want to come up there. And once they've done that, then others will join in.
I found it really helpful for me to have those discussion prompts because there were times when students didn't want to share, they were a little timid because they saw that they had the pitfall, but it helped them be anonymous about it and answering those questions that I had as far as what were on the prompts helped them open up.
I think the discussion builders provide the students, and actually the teacher as well, with the language to help push each other towards developing an understanding and working through misconceptions. I think that, for example, I remember moments with my 5th graders where a student would be up there at the board and what they were putting up there showed that they really didn't have a solid understanding. And one of the students would say, I'm confused about what you just put up there. Can you prove your thinking? And as a class then they would work through those mistakes until they had a solid understanding. I think another thing that the discussion builders do is help the kids develop multiple ways to approach a problem, so that for the student who doesn't understand one way, if the class is introducing like, I have another way to solve that problem, maybe they can understand that other student's strategy.
You wanted to talk about to remember to use the mini lessons.
I think that the mini lessons are incredibly important for reinforcing the understanding that students have developed over the 2 days of the main discussion. In the upper grades, there's 2 mini lessons. One has the format of multiple choice questions, and the second one has the format of guided writing. So it gives students different opportunities to demonstrate their learning. As a teacher, that's really important for me because I need an assessment tool to see where kids are at. And the 2 minis allow me to then say, okay, these students have developed an incredibly solid understanding, and these students might need a little bit more support in reteaching in small groups and the following week. I think a third reason that these 2 mini lessons are incredibly important is because they provide English language learners with the opportunity to develop their academic English skills. The guided writing assignment allows students to have an opportunity to really develop their mathematics communication skills. And in the upper grades, this is incredibly important for students to be prepared for middle school. I think finally, the multiple choice format of the first mini lesson is important as well because it allows students to have practice in applying their knowledge in a test-taking type situation.
There is one more thing we'd like you to remember. One of the best ways to learn how to use the program is to plan and debrief each lesson with another teacher at your grade level.
This spirit of collegiality will help you and your students succeed.